Considering with unit 4, that is ARM. So starting with, we go with the risk design philosophy. So considering this parameter, this is an acronym for the reducing the instruction set of computer. So we generally show that the risk is nothing but reduce instruction set computer, which can be a capability to having the reducing the instruction set for the computer. So RISC processor is a type of microprocessor that operate on small but very optimized instruction set in order to perform the various tasks, right? It based on the one instruction per cycle approach. So that approach is very important parameter related with the risk, that is a one instruction per cycle approach. That is approach will be mostly concerned for the risk uh, operating system related to that. So risk is an design philosophy aimed to end delivering a simple but powerful instruction that executed with a single cycle at a high clock speed. So this is a design philosophy and aim to be a delivering simple but powerful instruction. The risk philosophy concentrate on the reducing the complexity of instruction performing by the hardware. So, considering that risk philosophy concentration, it reducing the complexity of instruction performing by the hardware. The risk philosophy provide the greater flexibility and intelligence in software rather than the hardware. So, considering this parameter, the risk philosophy is implemented with four major design rules. First is the instruction. So RISC has a reducing number of instruction and classes. These classes provide the simple operations so that each will be executed in a single cycle. So first parameter to how it will be a make a RISC operation is a instruction which having very less number of instruction set and which can be executed in a single cycle. That will be a important parameter related with this one. Second is a pipeline. So the process of instruction is broke down into a smallest unit and that can be executed in a parallel by pipeline. So parallel execution is possible with a pipeline concept which can be executed the number of instruction parallelly. So that parameter is very important. And third parameter is the register. So risk mechanism having a large general purpose register. So we know that in ARM processor also having a general purpose register of R0 to R12 is like that one. Any register can be a contain either data and address. The register act as the fast local memory store for all data or an addresses. So considering this compiler and processor, so code generation will be possible with that one. Most of the complexity will be appearing at the compiler type in a RISC. So last parameter is the load store architecture. The processor operate on the data held in a register that is separate the load store instruction and transfer the data between the register bank and the external memory. So these are the four parameters which mostly consider with uh, a risk design philosophy. First is the instruction, second is a pipeline, third is a design, and fourth is a load store architecture. So this parameter is mostly considered for the philosophy of the risk. Same related with a philosophy of ARM processor. That is, ARM is an advanced risk mechanism design philosophy which is based on the principle of risk architecture. Focus on the simplicity, efficiency, and low power congestion. So whatever the complexity will be occur in a risk that will be reducing in a ARM design philosophy is mostly concentrate on the simplicity, efficiency, and low power consumption. The ARM processor uses a small set of simple and fixed length instruction that can be executed. So whatever it is a very small and simple fixed length instructions so they can execute it in a single cycle. So this is a possibility because of the single cycle of execution in a ARM design philosophy. So this design is the design philosophy reduce the complexity of instruction performed by the hardware uh, making it easier. So provide the greater flexibility and intelligence is software rather than the hardware. Most of the time they go with the software flexibility of that one. So, core design principle of the ARM design philosophy is first is a RISC architecture. So, ARM utilize a load and store architecture where data operate occurs in a register and memory access in a limited to the specific simple instruction, ensuring the quick execution. So, this the design is like a architecture which can be capable to execute the number of instructions which can be capable to store and ensure to quick execution. Then power efficiency, second parameter. It designed with a small silicon die area, which is minimize the power consumption and extend the battery life. So it will use the minimum power execution, and the life cycle of the battery will be increased because of less requirement of the power. Because of they design the small silicon die area. The high code density. The instruction set include the 32 bits arms and 62 bits thumbs variations. It's designed to be reduce the memory uses, right? Flexibility and performance. The ARM introduced the features like a barrel shifter. So that operation will be done also with the barrel shifter, which allow the complex operation to be a pre-processed before the ALU and conducting for the most of the instruction to be a boost. So that possibility will be done in a ARM design philosophy, which mostly consider also four parameters. First is the RISC architecture, second is the powerful efficiency, third is a high code density, and fourth is a flexibility and performance. So we considering this parameter, the philosophy is concentrated. So today's lecture we learn about the risk design philosophy. What is the parameter of risks and what parameter will be concentrated on the design philosophy. It consists of four parameters. One is the instruction, second is a pipeline, third is a register, and fourth is a load store architecture. And ARM design philosophy concentrate on the RISC architecture, power efficiency, high code density, and flexibility. So this parameter is concerned with the philosophy of risk and philosophy of the ARM processor, right? So that concerned with the this lecture related with the uh, parameter, right? So concentrate on that one.